We have everybody here, any latecomers. So let's get into it. So again, as I started to say at the very beginning, thank you all so much for giving me your time on this Monday afternoon. My name is Katherine Munro. Welcome to AI in Marketing, the Power of Personalization. And I'm going to take you through an hour of really exciting ways that AI is revolutionizing marketing. I'm going to tie this into data science because I know a lot of the listeners who've come through Brainstar are studying data science. And there'll be plenty of time for questions at the end, but also anytime you want to put a question in the chat, please do. I will try to keep an eye on it and answer the question at the right time if it's appropriate for that moment. Otherwise, I will get to you at the very end. So let's jump into it. So a little bit of a background on me and what my winding journey has to do with data science. So I have done a lot of things in the past. All the time while I was studying, I was working, for example, in sales, marketing, customer service, even music, playing in a band, and teaching. And I studied a lot of things too, some design, some marketing, and ended up in linguistics, which is the scientific study of all the languages in the world. And this was really, really fantastic. But I did want to try to make this a little bit more real world, so work on real world problems that users are dealing with all the time. And of course, I still had a little bit of that hustle from my marketing days and my creative days. So I decided to try and specialize in the field of linguistics, and I moved from Australia to Germany to study computational linguistics, which is combining that linguistic knowledge with programming and with AI technologies, and using that to develop things like neural machine translation or Amazon Alexa, chatbots, things like that. And I was lucky enough during my master's degree to get a lot of practical experience. I was working at Mercedes-Benz, helping them develop the user interface in their car, so this voice that speaks to you in a Mercedes-Benz car. And I also wrote my thesis at the Fraunhofer Institute. Now, you might not know their name, but you definitely know about them because they invented, for example, the MP3 and many, many other technologies that are in every one of our smartphones. So I had a great opportunity to work in their natural language processing department for my master thesis, which was about deep neural language models, how they perform natural language understanding, and what they actually learn about language. And once I came to the end of this time, I really wanted to dive into industry and get working again on real projects, and that's what I really loved. And I found my job at Smarter E-commerce, and I'll get to that in a second. But basically now I'm a data scientist, a data science ambassador, which means I actually teach about data science, and I'm the education lead for Women in AI Upper Austria, and a mentor at Female Coders in Linz. We teach women how to code. So yes, very busy, but it's just such a fascinating world that I want to be in it. And my current job at Smarter E-commerce, we use targeted research to try and understand consumers and machine learning to try and predict the performance of different products under lots of different shopping conditions, because markets are just by nature very dynamic, which is what makes the problem so complicated but also fun and interesting. And basically, why am I telling you all of this? Well, the bottom line is that if you're a creative person, or maybe you're a very analytical person, but either way, you think that it would be quite cool to be a detective and a gold miner mining through data for really valuable nuggets of information, and a fortune teller because you're predicting the future of machine learning, then you can come to data science even from maybe quite diverse backgrounds, as I'm sure a lot of the Brainstar students definitely have. And you can apply data science to almost anything and find a job that you will really love. And today is basically all about one specific field where that's applied, and that is, as I said, marketing. So let's dive into it. Let's start with how the situation is right now. So what are we dealing with? So today's customers, that's you and me, all of us. We are distracted. If anyone's already been checking their phone while I've been talking, then you know you're guilty of this. We're time poor, we have no time, it's so busy, but we're tech savvy, okay? We know how technology works to an extent. And we've been trained by the likes of Google and Amazon to get what we want right now, right this second. For example, we want to be able to buy an insurance policy with the same speed and convenience that we can order a pizza through an app. That's what we're simply used to. And this means that companies can't just compete against each other anymore. They have to compete against the best customer experience, even if that is in a totally different domain. And the result of this is that customers expect brands to convey the right message with every single communication. And this is called an attention economy because, our attention is so valuable. And in this economy, if you're a marketer and you put out some kind of message or make some ad or something which doesn't resonate with consumers, then at best this is simply a missed opportunity and a missed sale. But at worst, it damages the reputation. And this is not just theory. There's industry research companies that do a lot of surveys on this. And for example, there's been some findings that 81% of consumers want brands to know when and when not to contact them. And 63% of consumers expect personalization as a standard and believe they're getting personalization and being treated as an individual when they get a special offer. So even if you're someone who tends to swipe those push notifications away for special deals, actually over 60% of people feel that is a benefit to them. It's a personalized service. So marketers really do have to be aware of that and adhere to that. But how did we get to this situation? So let's go a little bit back in time now to the development of personalization in AI. So in the early days, it's still true, it was always true that understanding consumers is vital. But back then, the required information you needed to get that kind of understanding was quite hard to attain. We simply didn't have the ability to get the data, store the data, and process it. So marketers had to use assumptions and trial and error about what certain types of customers might want. So they had to make a guess and make an ad and try it out and hope that they were right. And this is, of course, not particularly efficient. And things started to change in the 90s with some really basic rule-based personalization using CRM software. So that's short for Customer Relations Management. And these still exist today, and they're still a very rich source of data for marketing and machine learning, for example. But they're databases with details about the customers and maybe any interaction that customer has had with the brand or any time that a salesperson has contacted them. And through those CRM services, you were able to have, as I said, very simple rule-based personalization, like greeting someone in an email by name instead of dear sir or madam. And we're used to this now. We expect this. And if you get a dear madam in an email, you actually feel somehow let down, like the brand doesn't care about you enough. But once upon a time, even this was quite special. Or another example is getting an email on your birthday with a special discount. This was only possible with this advent of this early CRM software. But it had limitations. So this all works based on customer types. You have to have a different marketing strategy for each of your different customer types that you have identified. But that's a manual task. And this requires a lot of looking at the statistics and trying to guess what kind of customers exist. So the number of segments you could build and how fine-grained you could be was just simply limited by the effort required. Another problem was that marketers had to decide, instead of learn, what content to show which visitors. And of course, it would be better if they could learn somehow, maybe with a machine. We'll get to that. And another problem is that data was restricted to the information from customers who are logged into, say, a retailer's website. It's not like now where you have this so-called omni-channel view, where because of tracking cookies and things like this, you can know where a customer is going on lots of different websites. This was not a factor. Back then, you simply had to hope that they would sign up to be part of your list of registered customers, and then you would have a little bit of information about just what they did on your website. So we've come a long way since then, and there's been a few evolutions, and this started to bring out a new challenge. So in the 2000s, social networks started to collect the data that was required for all of these tracking tools and insights. And we also were getting better and better at A/B testing. And this is for anyone who's maybe not in marketing, which is I guess the majority of you, this is very common in marketing, and it involves running two different variations of something, say a website A and website B, different landing page, and only one aspect of each variant is different from the other. And after a set time, the performance of these two variants is compared, and since only one aspect is different for each one, then you can sort of say, okay, this one performed better according to whichever metric you're working with, and so we want to keep this variant. And so this might be a new landing page for a website, a new email format, a pricing strategy, and so on. So A/B testing is something that is not new, and marketers have been working on this for a very long time. And so it was starting to evolve, and they were starting to get better segmentation strategies for even more fine-grained categories. But we have a new problem. We're getting so much data, and it is simply too much for any human to be able to do anything with. It was a marketer's dream and a curse. So this is where we, quite luckily, get to a turning point, which is where we start to see the benefits of big data, compute power, AI, and machine learning. So the situation is now that big data techniques can be used to collect and process huge amounts of behavioral data for analysis from lots of different sources without that problem of needing them to be logged in. And by behavioral data, I mean things like email clicks, shopping cart history, and so on. And this is gathered by cookies. For example, if you sell in the Google universe, like a lot of the customers at Smarter E-commerce where I work, then there is Google Analytics, which is available to you, or other vendors of different marketing, maybe machine learning based products might offer you a tracking link which you can embed into your website. So this is how you gather behavioral data. And AI is able to leverage many, many variables within that data that reveal how, when, and what customers shop for. And these variables, they're not just the obvious ones you might think of, like demographics, age, and gender, and so on. They can be contextual data, and context is always, where is this person right now? Not necessarily location-wise, but maybe where are they in the menu on a website? Where have they been clicking so far? What was their journey? So this is contextual data. You do have demographics. We have variables that detail expressed interests, maybe customer rewards programs, even local weather is often used to personalize marketing, and time series data, which will reveal trends that have taken place. So obviously every Christmas, sales tend to go up like this. And so AI can leverage all of these variables, and then machine learning can identify patterns such as customer needs from this data and use those patterns to make predictions about what customers will want in the future. And what really turbocharges all of this is that we now have GPU-based compute power. So GPU, this stands for graphics processing units. So these were first used in gaming, actually. They were designed to speed up those processes that do the world building, so rendering shadows and textures and so on, because this actually just requires a lot of linear algebra, specifically matrix and vector operations, which is, don't worry, I'm not going to go into a crazy maths lesson. Matrix and vector operations is doing lots of multiplications on, say, grids or series of numbers. And these GPUs would do this in parallel, so they'd have multiple jobs running at the same time, and this made them very fast. And the lucky thing for all of us here is that neural networks require the same kind of parallelization. So once these GPUs became popular, some clever scientists said, why don't we try this for these machine learning problems we've been working on for years? And boom, suddenly everything performed so much better, we were able to do so much more, and this is why the industry took off. But fun fact, neural networks are not a new concept. They might be a buzzword, but the first work on neural networks started in around the 40s and 50s. And back then they just weren't able to do very much. They were making very simple predictions. It's almost cute when you read those early papers and they have a series of numbers 2, 4, 6, 8, and they have to train this neural network to predict that the next number is 10. It's a long shot from what we're doing today. But I digress. The point is that now we have GPU-based compute power, and this lets us build ever more complex and usually more accurate models for a huge variety of tasks. And I say usually because these bigger models also need a lot more data and a lot more training time. And this is actually often infeasible for real companies in the real world. So outside of academia, many organizations actually don't have the resources to train such big models, which means that the models are not necessarily better than a more simple option, say an older statistical machine learning model. But in any case, we are now able to do so much more with a lot more data that we have available to us. And what is the result of all of this? Well, to look at it from a marketer's perspective, there's a few benefits. So we have more granular segmentation. So this is identifying really specific customer types. It's no longer about having a customer group that's called women under 30. It might be women aged 24 to 27 living in this area with an affinity for gardening, whatever it might be, and a high price sensitivity that likes to buy things that are on sale. You know, that's how specific we can get with the segmentation. And when you have really specific customer types, when you've identified those, you can do things like apply that to product development, so to make products that will more specifically appeal to more specific audiences. You can, of course, make specific pricing strategies, different targeting strategies with your messaging and so on, and different measurement strategies in terms of expected performance on different campaigns. And the really great thing about using machine learning to identify customer segments is that this will work even for new customer types. So imagine what happened a couple of years ago when everybody on the internet started searching for vegan and bio products. Well, this was new and this wouldn't have fit into existing customer types, but all the classification algorithms would have kind of started to make an other, and eventually we start to realize, okay, this is a new type, this is a rising trend, and then sure enough, all the marketers start advertising vegan and bio even more. So that's how this works. Another benefit that all of this new technology brings for us is more accurate attribution. Attribution for the non-marketing people is about knowing what contributed to a sale. So this more accurate attribution allows us to understand the customer journey, which channels and touch points are the most effective, and which content drives the most results. And once you know this, you can get a better return on investment from your marketing efforts. We're also able to do predictive analytics now, which is about providing insights into customer needs, industry trends, and intent signals. So what do customers want? Not just now, but in the future. As I said, what will customers want maybe next year? And this is useful for inventory management, which is about deciding how many products, what kind of products, and all of this sort of thing you're going to keep in your warehouse, as well as the marketing strategy. And lastly, we have predictive marketing. So this lets marketers adjust to customers' next actions and experiment with personalized experiences with the confidence that their content will be more contextually relevant. And contextually relevant means the right customer at the right time, the right format, and the right channel. So mobile, desktop, email, whatever the case might be. So predictive marketing is about trying to determine, okay, if I put this message out, will a customer buy or will they give me a bad review? And based on your prediction, then of course you adapt accordingly. So we get one little bonus with all of these benefits, which is that all of this can now be done more easily, at scale, and over the entire customer journey. So the customer journey is that moment from search, so when they first Google something and they land on your brand, to making a purchase, to making repeat purchases and being called loyal, a loyalty customer, and then advocacy, which is when they start telling their friends. Another great thing is that marketing data, like clicks, time on a website, and actual purchases, of course, is very often high volume. So some customers that I've seen are getting thousands of clicks a day. And this is great because it lets you train machine learning models faster, and therefore it makes it easier to test different personalization techniques, because let's say you're doing an A/B test, you don't have to wait as long before you get enough results to see whether your outcome is statistically significant, that's always hard to say, or not. And lastly, let's not forget about the consumers. So for you and me, the experience becomes easier, more relevant, personal, and human. And the gap between the physical and digital worlds can be bridged. And this is particularly relevant in the last few months with everybody being at home, especially when the shops were shut, because some people really do like to be able to go into a store and talk with a real person and get advice. And of course, once everything went online, the store can't set up a Zoom meeting with every one of their shop assistants, so we were kind of stuck. And by being able to do some personalization techniques, like having really clever chatbots on your website, for example, which I'll talk about towards the end, then you can halfway bridge this gap between, you know, the experience of going to a real store and shopping online. So, before I move on, I just want to remind everybody that if you have any questions, pop them in the chat. I'll answer them straight away if they fit in this part, and otherwise at the end. So I hope everyone's doing okay. And let's dive into something a little tiny bit more technical now, but don't worry, we're going to walk through it with some examples. So I'm going to show you a bunch of examples of AI and machine learning being applied to real problems in marketing now, and how each of these different areas is affected by and being, to be honest, revolutionized by these technologies. So we don't have the time for me to explain exactly how every model in every one of these examples works. And of course, I don't know, I don't work there. I can just use my data science knowledge to make assumptions about how these products work, but even that would be way too overwhelming for you guys tonight. So I'm not going to say how every single solution works, but we're going to go through how you would try to work it out for yourself, because that way in the future, if you are on a website where they say, wow, our AI-based software does this and this and this, and you think that sounds fantastic, you can maybe think, I wonder how they did that, especially if you are studying data science and you want to get into machine learning engineering. So, how to interpret an AI solution. So, basically, all of these examples are going to involve machine learning, which is about predicting a target variable based on patterns in some input data. That's it. So, machine learning is pattern recognition. It's recognizing one pattern in a bunch of data from the past, and then being given a new example from the future and being able to say not from the future, a current example that the machine has never seen before, and then predicting what the outcome is going to be based on those patterns. So for you guys, when you're looking at these examples that I'm going to give, you can infer how they work by asking yourself, what hidden variable would you need to solve this problem? And what kind of information could help you predict it? And by the way, bear in mind that most of these solutions still need a marketer's know-how, and they might have automation rules on top. And so especially if there are some people here who are purely in the marketing branch, they're not doing any data science or machine learning, don't worry, AI is not going to steal your job, because we still need this combination of machine and human intelligence, and a lot of these solutions will, yes, apply some kind of automation rule once the machine learning model has output its prediction. So let's take an example. So let's say the problem is that you want to create personalized loyalty incentives for individual customers. So depending on how valuable the customer is to you, you want to be able to give them some kind of reward. And so your target variable, so that's an important term, your target variable is the customer lifetime value. This means we're going to be building what's called a propensity model, which is basically predicting how likely a customer is to do something. In this case, how much is a customer likely to be worth over their lifetime with the company. And by the way, lifetime doesn't mean a human lifetime. It means how long they are a customer of the company, which might be as short as one transaction, or it might be years long. So the input information, or we should better say the training data, is going to be things like the purchase history and the demographic information per customer for all customers. And then the inference, or the test case, will be the purchase history and demographic information of a single unseen customer. So it will look like a single example from the training data, it's just that the machine learning model will never have seen it before, and it's going to have to predict what this customer lifetime value is. And then an example automation rule that you might put on top is something like, okay, if the predicted target variable is above a certain amount, say above 5,000 euro, you might offer this kind of incentive. Let's say maybe it's predicted that it'll be between 4,000 and 5,000 euro, And so then you really want to just nudge that customer up into the €5,000 group, so the really valuable group, then you might offer some other incentive and so on. So we'll go through an actual machine learning algorithm now. So an example, this is a hypothetical one that I have made up. And this is training a decision tree for customer lifetime value prediction. So what is a decision tree? Well, it's a machine learning algorithm that tries to learn a tree-like structure of simple decision rules from some training data, which can then be used to classify future unseen inputs. So each rule tries to split the data points into these branches based on some feature, some aspect of the data. And it tries to split this in a way that the two resulting groups are very different to each other. Okay, so they're way far apart from each other, but within them, the items within these groups are quite similar to each other. And let's follow the tree all the way down. So let's say we start with the data coming in, and let's say that the first most useful way it determines to split the inputs is based on whether this customer is a registered user, so you actually have an email address with a whole profile and previous transactions and so on, or they've maybe made a purchase just as a guest. So all you have is maybe the email address from one purchase, that's it. So the model learns to first split the customers into these two branches. Now let's follow the guest side because I've made this a little bit simpler. So let's say that if the customer is a guest, then the next best way to split up the data is based on the number of items purchased. So if they've only purchased one, then maybe there's a very good chance that this is the first and last time the customer is ever going to buy something with you. So in this case, the next best way to split the data might simply be the product value. So if it's less than €100, the customer lifetime value is usually this amount, and if it's over €100, then it's usually higher or lower, whatever the case might be. And you end up with getting to a point where you've got a bunch of customers, like a bunch of customer records, and there is no better way to split them. There's no way that splits them it's about information gain that gives you more information by splitting up. So then you just stop, the tree stops, and this is called a leaf, and the average customer lifetime value of all the customers in each leaf, that becomes the prediction for those customers. And we can go on, if we go all the way back up the tree, up to the top, to the all data, let's come back down and go member, and let's say, yes, it was a registered user, so you have a bit more information about them to work with. Then maybe the next best way to split the data is based on which points tier this customer has achieved. So I'm sure you know that some loyalty programs will allow you to progress from a lower to a higher level depending on what you've spent so far. And let's start with gold because again I've kept it simple. Let's just say if the person is a gold member, then I've written ... to just say other splitting attributes. I didn't expand this tree forever, and then at the end you get to a point where there is no reason in splitting the data any further, and so you can make your CLV prediction. I've done the same for the silver, but let's say if the customer is a bronze level in this loyalty program, then maybe the next best option is to split the data based on the days since the last purchase. So if they've purchased in the last 14 days, then the likelihood of a certain customer lifetime value is maybe quite different to all the customers that bought earlier than 14 days ago, and so on until again you get a customer lifetime value prediction for them. So this is a decision tree. Now, if any of you are coming from the machine learning, data science side, you might be thinking to yourself, a decision tree? What about a forest? Because I've actually simplified this a little bit. Decision tree is maybe not so likely. What's probably more likely is that you might use what's called a random forest, which is when you actually build hundreds or even thousands of these decision trees. And each tree you introduce a little bit of randomness into it by not giving it access to all of the data, not giving it access to all of the features. And each tree will make errors, but then in the end, you put all these trees back together and you take, when I say put them back together, what I mean is that you take the average of their predictions as your final prediction. And this is really good because Each tree usually makes a lot of mistakes because of that randomness that you introduced into the tree. So for example, one tree might always over-predict the CLV and another tree might always under-predict that. But the good thing is that because these errors are random, they tend, just statistically, you just got to believe me, they tend to cancel each other out. And in the end, what you get is a much more robust predictor, so something that works better on new examples it's never seen before and tends also to be more accurate. So this is actually just one component of a random forest, but I couldn't fit a whole one on one slide. So I hope that didn't scare you off too much, but that's about as technical as I'm going to get, unless of course we have questions. I'm happy to answer more technical questions, but for now, let's just dive into some examples and some use cases. So one or two main areas that are being really changed by AI in marketing is optimized emails and personal messaging. So marketers are able to, using machine learning methods, it won't necessarily always be a decision tree or random forest, by the way. This is just one of many, many algorithms. It's just an easy one to explain. But using machine learning, marketers can predict engagement of different subscriber types for different conditions and content when it comes to email, of course. And then they can automatically create dynamic emails based on factors like previous email and website interactions. So did it go straight in the spam folder or did someone actually read it? What products or content did the user view? So it's not always about products. It might be, Huffington Post sending you out a weekly summary email or something like this. So it can be also content. Time spent on the website, even more general information like the most popular current content, regardless of customer, and the behavior of similar visitors. And so, marketers are able to use this information to tailor their email strategies based on how they predict people will react to different kinds of email. Another really popular option is push notifications. And they're popular because they create this positive feeling of receiving a personalized text. So they tend to be more engaging. And this is great because even engaged customers, so even customers who really do like a brand and connect with a brand, they often have a promotions inbox or even a junk filter that will get the promotional email before they even got a chance to see it. So push notifications can break through a little bit better, which is great. Even things like the timing of when you send these messages can be optimized. So the moment customers usually check their inboxes, for example, because this is more convenient for them and leads to higher engagement. Or, and this is quite cool, you can even combine this with geolocation services so that you could, for example, trigger an alert when a user visits a store. So if you have a membership to some kind of shop and they actually visit the store in person, then it can say, "Hi, John Smith, how are you?" And maybe tell you about a discount on a product that you looked at last time on the website but didn't buy, something like that. So let's start with an example that we all know, Tripadvisor. So they're very good at this. So they use customer data based on previous trips and website browsing to detect and predict attractive locations and different activities that people will like, different things like this. And they send helpful curated emails about them. So if anybody remembers back when we used to be allowed to travel and we would book flights, then you would get a follow-up email from Tripadvisor saying, hey, here's this great 5-star restaurant and here's a really popular beach you could go to, and so on. Another example is Starbucks. So they have a loyalty card that you can use to, tap when you make a purchase to record your purchases. And they also have an app that you can use to place your orders in advance when you're, in a hurry on the way to work. And by combining the data from these two sources, they use predictive analytics to determine effective personalized messages to send through the app, such as, again, a greeting or a cross-sell. They might say, hey, it's October, it's your favorite pumpkin spice latte season again, or things like this. And they can do that as the customer is walking up to the store. So another example now is, so this is another area of marketing that is being assisted by AI and machine learning, and this is tailored recommendations and assistive search. So as I touched on at the beginning, customers expect customized shopping experiences, And they want the benefits of offline shopping, like having a person to speak to, even when they're shopping online. And so to deliver this, there's a thing called recommendation engines. And these use customer, product, and site traffic data to learn relations between different kinds of customers, products, and content. So let's play dictionary for a second now. Let's just talk a tiny bit about recommendation engines. So there are two kinds of filtering that are used to deliver those recommendations. Firstly, content-based filtering learns to recommend similar items based on their characteristics, like having the same brand as a just viewed item. And this is useful for first-time visitors, and I'm sure you've had it before, that you have been on a website you've never visited, you've started browsing, and suddenly maybe you've only clicked 2 or 3 products and not very much, but down the bottom they'll have recommendations for maybe jeans in the same color or jumpers by the same brand and so on. So content-based filtering is all about the products and what makes those products similar to other products. And then we get collaborative filtering, which recommends similar items based on how groups of users have interacted with them. So this is useful for returning visitors when you have a history with the brand. So let's look at an example or two. Amazon. We can't talk about recommender systems. I can't talk about recommender systems at all. I can't even say it. We can't talk about recommender systems at all without mentioning Amazon. So first, they use collaborative filtering to match each user to similar users. And then they use content-based filtering to match the purchases of, the user group A to similar items that they can then recommend. So basically they say, okay, what kind of customer are you? Great, you're this box. And then customers in this box usually buy this product and this product, which are similar because of X, Y, Z characteristic. And by having a really good recommender system, Amazon has this impression of authority, of having everything, of knowing exactly what passes together. And this, of course, increases the margins when the additional value exceeds the additional shopping costs as well. So it's when a website offers you free shipping above a certain value, it's not necessarily that that's their break-even point where they can afford to ship it to you for free. It's probably their break-even point is a little bit lower, but they would like you to buy that little bit more, because if they can get one extra purchase with only X amount of extra shipping, then of course they're increasing their margin. So that's what's happening there. And by the way, with the Amazon Assistive Search, this is really interesting from a point of view of explainable AI, which is a topic for another day, but explainable models are very, very important. Customers like to know, or all stakeholders like to know, why a machine learning model predicted what it did. And this is why a few years ago, Amazon switched from just saying, you might also like, to saying, customers who bought this often bought this. It's a very simple, small change, but it just shows you subconsciously that, there's a reason these are grouped together. And the groupings might even surprise you. So you might be looking at a toy. This is actually a bit of an obvious example, but I can't think of a better one. You might be looking at a toy and it advertises batteries. And that's not a toy, but of course the toy is battery powered and it doesn't come with batteries. So this is an example of how the recommender system works in action. Another example that we can't go past is YouTube, where we all are sitting today. So it gets more revenue from ads than from subscriptions. So this is why the YouTube Prime memberships are not completely forced upon you or something, because YouTube is still making money from ads, in fact more money. And this is why they work hard to show you exactly what you want. And another example is a UK clothing retailer called ASOS. They have a fit assistant, which provides sizing recommendations based on the past transaction history, knowing which customers have bought what and what has been returned and so on. And of course this is great for customers because it's really, really annoying to buy something that comes and doesn't fit. And it's of course a huge loss of revenue for the shops when they have to pay for all the shipping and they don't even get anything out of it. And now I'm really excited to bring in my first local spotlight. There's going to be a few of these in this presentation. So on the topic of sizing recommendations, Precise AI, they're based in Munich. And they have very cool technology. I encourage you to have a look at the website. And they use computer vision to make a 3D model of a user's body from which they can determine a shopper's body measurements. So actually what happens is you set your phone up somewhere and you just turn in a circle. You stand there and you turn in a circle slowly and it builds this 3D model. You can see on the image there that it says record, so it's recording a little video. And it calculates the measurements of this person, and then it can provide sizing recommendations for them. And this is, of course, more convenient for a customer than answering questions. It's also, depending on how you look at it, a bit of fun. One of the overall themes of this talk, when I was researching it, is that a lot of examples are designed to just delight customers with something new they've never seen before. So this is better than questions. It's maybe a bit more fun. It doesn't need as much product data so the catalogue of the retailer doesn't need to be as big, because the recommender system can learn from not only the product data they have, but also the sizes and what customers have bought and what they have then sent back. And it can even be product specific. So you know that some brands are notoriously always too big or too small. Well, hopefully the retailer has this information anyway and they can feed it straight to the model, but even if they can't, then the recommender system can learn from the returns that, customers who are buying this size always end up swapping it for a size smaller, so this brand has obviously slightly larger sizes. And the software provides sizing recommendations. So there's a local example that you can check out. Now, another factor in this category I've created of tailored recommendations and assistive search is, assistive search. So this is about search that helps you. It's not just about you typing something into a box and seeing what the results are. It's about guiding you along the search journey, maybe by asking you questions, saying, hey, what do you want today? What can I help you with? And so on. And this is becoming even more common, especially with the rise of what's called conversational commerce. Google that term because it is coming. It's going to be the future within the next couple of years. And conversational commerce is coming because of advances in natural language processing, which is my field that I studied. So this is very exciting for me. So an example is the North Face. So they are an outdoor clothing retailer, and they use IBM's Watson to enable online shoppers to discover the perfect jacket. The way they do that is they ask customers questions about their intended use. So will you go, what sort of activities will you do? Where will you be? Different things like this. How hardcore do you treat your clothes? Whatever it might be. And Watson can make recommendations based on the product data and additional sources such as typical local weather. So, maybe this exact same technology applied here in Linz and back in Australia where I'm from would recommend very different jackets, I'm guessing, based on the local weather. Another US department store, Macy's, used Watson to create a personal shopper, so an AI-based shopping assistant. And another company is Sentient Aware. So they have this really cool little pop-up that you can have on your website if you're a clothing retailer, and it's a visual filter. So it lets users click images of products that they like instead of having to search. So if you might just search stilettos, or you go to the stiletto part of the menu, and then this window will come up with lots of different kinds of these shoes. You can click the ones you like, and then it will serve you recommendations. So it understands, using image recognition as well, what customers like visually. And there's also a new extension from Pinterest for Chrome, which is very cool. Users can select an item on a photograph on any website and preview similar images from Pinterest. So let's say you're on a clothing website and you actually clicked on a jacket and the model has the whole outfit on, but you've really just fallen in love with those sunglasses. You didn't know you need them, but now you do. And then with this extension, you can draw a little box around it and Pinterest will show you similar examples. And this is another example of assistive search, and it's quite fun and novel and new, which is a great way to get customers as well. Now we go to another area that is being improved, which is dynamic websites. So the thing is, A lot of websites are already using some kind of machine learning to customize their content, learning from non-specific customer data, like for example, trending topics. Maybe if the whole country is talking about one topic, then it's a good idea to put that topic at the top of your page if you're a news website or a Huffington Post or something like this. Another non-specific customer data source could be common searches, so Google search trends and so on. And these can be used to create search prompts. So if you've ever been on a website, you start typing in looking for a product and it autofills some suggestions. Well, this doesn't have to be learned from you and your specific typing history. This can be learned more generally. And websites also use location to localize the experience. This is pretty normal. We know that a website with lots of different languages will usually localize to your language of your area. But we can get more sophisticated than this. So AI can use live behavioral signals to decide what to serve, and it can adopt this continually instead of waiting for results as required by the old A/B testing that I mentioned right at the beginning. So this was often a waiting game, not anymore. So for example, based on the predicted likelihood that a browser who's on a website is going to click something, or that they're going to add it to a wish list or make a purchase, you can dynamically serve personalized content or special offers, things like this. I've even heard of examples of websites like retailers that completely reshuffle their menu. So the whole design of the website based on what kind of customer they identify they're currently dealing with. And of course, this would be done with something like collaborative filtering. So it can discover different visitor types and provide them with an involving, tailored experience. So let's look at YouTube again for an example of this. So they use Google Brain's deep learning technology, and this has 2 neural networks. By the way, I didn't plan in this talk to discuss neural networks, but if anybody does want to go into that, then just pop that in the chat and we can come back to that at the end. So YouTube uses 2 neural networks from Google Brain. The first neural network takes information on videos, on people's playlists that they've created and so on, to select hundreds of candidate videos that match your search. And the neural network takes user feedback like plays or thumbs up or thumbs down, and it learns to rank those recommendations. So when you do a search, it doesn't rank all 20 billion videos that YouTube has, or however many they have. It first uses this first neural network to maybe choose 100, and then the second neural network to rank those. And if you were savvy, you might have noticed that this was again a case of content-based and collaborative filtering going on there. And what's really amazing is this is even done according to your current mood, and it improves constantly. So if you're like me, I have different music playlists depending on my mood. And as soon as I type Justin Timberlake into my search bar, I'm not afraid to admit it, then it knows I'm in a mood for 90s pop music, and all of its recommendations will change. But if I put in some old 80s Australian rock song in the search bar, then also the recommendations will change. So you might not have ever thought about that, but it's quite remarkable that YouTube doesn't just know what you want, it knows what you want right now. And it knows that that might be different tomorrow. And this is called stickiness, and this is achieved by the likes of Netflix and Spotify as well. Another example is HSBC Bank. So they're a global bank, and they tested AI-driven dynamic content against static content on their website. So the AI-driven content would be changing depending on what kind of user they think they're dealing with. The static content is just always the same. Again, classic case of an A/B test. And they found that this use of AI drastically increased their click-through rates. CTR stands for click-through rate, to the different product pages. So let's take another spotlight again. So 506 AI, they are based in Linz in the tobacco fabric, and they aim to deliver unparalleled personalization. This is their claim. So I really recommend checking out their website as well after this, because this is their unique selling point, their USP. And of course, they hope that by delivering better personalization, you ultimately get a better customer experience. And they have lots of services like dynamic ads, similar to what I just mentioned from HSBC. So these are, they say, built using data plus creative mind. So in other words, you're going to have designers working with some kind of, I guess, predictions from a machine learning model to develop different tailored ads and so on. And an example they give is that, let's say it's raining where your customer is and you sell raincoats, then you can show a banner. And of course, if your customer is somewhere where it's not raining, then this banner is not relevant and it won't be displayed. So this is really how personalized things can get. And it's nice to see another local company. Now we come to personalized products and services. So for products, it's simply not true anymore that one size fits all. So for example, sentiment analysis, which is a technique in natural language processing, or it uses natural language understanding to understand text. And this can be applied to reviews, social media comments, and service emails to discover attitudes and trends and tailor products and marketing to reflect that. So this is really personalizing products based on user feedback. So for example, not an example with sentiment analysis, although I do have one on the next slide, but another example of personalized products is insurance. A lot of insurance providers use machine learning to learn which specific factors influence risk. And this is used to create individual, more accurate insurance policies, which saves all customers money. Now let's think about this. What this means is that if these machine learning models are going to learn based on things like your demographic, where you live, the roads around your area, the traffic data for your area, the weather data for your area, all these sort of things, they're going to learn that you, customer X, have so-and-so of a risk of, say, crashing your car or having your car stolen, and another customer might have a different level of risk. And then there will no longer be one insurance policy, or, usually these websites have, say, 3 insurance policies, really basic, somewhat basic, and super fancy. There won't be this anymore. There'll be a policy for customer A and a policy for customer B, and the price will be really, really accurately tied to the predicted risk. And yes, someone with a very high predicted risk will have a higher premium than a customer with a low predicted risk. But in general, everybody will save money because the prices are more accurate, and so the insurer doesn't have to lump as much extra on top just for safety, just as a puffer. So this is a really current example of machine learning being used for personalized product development. So Google that as well if you like, that's really interesting. Another very cool example was the Nike Makers Studio. So they invited customers who had purchased a lot through the app, so really loyal customers, to come to the studio and design their own shoes. So they would stand in this room on a white platform, and all around the room there would be lighting and there would be augmented reality, so projections. And the customers could make a design, it would be projected onto the shoes while they were wearing them, so a pair of plain white shoes at the beginning, and they could perfect their design until they were really happy with it. It would be printed within an hour and they could buy it and take it home. So this is, of course, really fun and novel, so it's great for publicity and so on. Of course, they sold really well, but most importantly, Nike scored real customer preference data that can be used for future designs. Because think about it, normally what Nike has to do is make a design and see how it sells and then realize, oh, okay, customers hate this color. Now they can do this the other way around. So this is a very cool example. And now I mentioned sentiment analysis on the last page. And again, I've got a local spotlight for you, Deep Opinion, based in Innsbruck. So in case you haven't noticed already, the AI scene in Austria is really going strong, which is really great to see. So at Deep Opinion, they are industry-leading providers of sentiment analysis products. So this is this one I mentioned, social media listening, for example. So they have a customer experience solution which applies natural language understanding to things like reviews, complaints, and surveys. And this enables customer service teams and marketers to find areas for improvement. So you have to look at this example, this image, to really get what's going on. So we've got 2 reviews here. The next metro station is a 5 minutes walk, and a smelly factory is 5 minutes away. Okay, so Metro station, probably a positive thing for, say, a hotel review. Smelly factory, this is obviously bad, so it wouldn't take a very clever sentiment analysis machine to know that smelly is usually bad. But this is the challenge, 5 minutes walk. I just realized I've been pointing with my mouse and you can't see my mouse, so I hope that you've been following along anyway. So in these two samples, one has 5 minutes walk and one has 5 minutes away. In the first case, 5 minutes walk is a good thing. In the second case, 5 minutes away is a negative thing. And sentiment analysis is all about learning from many, many such reviews, all which have been labeled with positive or negative, maybe neutral, learning to classify other reviews as positive or negative. And of course, if a hotel was to run a list of all the locations that are being listed as negative, then they might see, oh, smelly factory, yeah, okay, we do have to deal with that. I'm not sure how I can deal with a factory, but it would give them a to-do list somehow. Or if they see that 90% of their reviews are negative, then they could make a strategy. So this is what social media listening is all about, and it can be used for product development and improving services. And then we come as well to services that are improved by AI, and that is chatbots. So AI can reduce costs and provide a better experience. So with chatbots, they're more capable because they can, I don't mean to say that they're smarter than a human. We are not at the stage of artificial general intelligence yet. If that happens, that's going to be many years away. But what I mean is that chatbots can simply process more information than a human possibly can. They can have access to all the records of a customer going back years and so on. And they're available 24/7 for customers. And of course, they don't cost much for the company. And it's not a case of one chatbot per customer. You can have one chatbot serving many customers at the same time. So they're a really great solution for actually both parties in this case. And a nice example here was Harley-Davidson's Albert. This is a chatbot which flags potential high-value, lower funnel customers. What does lower funnel mean if you're not in marketing? When we're talking about a customer going on a sales journey, we talk about it like a funnel. So all the customers come in at the top, or the potential customers, that is, they come in at the top and they maybe haven't had many interactions with you. Their intent to purchase is maybe not so high. Maybe they're just shopping around. So this is not a hugely promising prospect. But then we get slowly more and more specific, and the intent from the customer becomes more obvious. So if they, for example, click one page on your website and then they click deeper and deeper into your product tree, then you could even think of this like going down the funnel. They're getting more and more specific with what they want. And so a low funnel customer is someone who knows exactly what they want and is just about to make a purchase. And for Harley-Davidson, this bot would identify customers who might be in that low funnel situation, and they could then be contacted by a customer service person for assistance right when they need it. Now, obviously, this is good for Harley-Davidson. The salesperson can push the customer over the line, but buying a motorbike is a lot of money. This is not something that you necessarily want to do just on a website. So it's nice to have that personal contact from a salesperson. And we have another local spotlight here, Onlim, based in Vienna. So they create conversational chatbots. So they are, I'm just going to read straight from the website what they say, because this is exactly summing up what I'm talking about with what chatbots can do. So they say that you can connect all the relevant components of an integrated e-commerce solution for product search, recommendations, offers, promotions, and more, and build a chatbot whose knowledge goes far beyond answering FAQs. What does that mean? It's like I was saying about a human can only process so much information at once, but a chatbot can know all about the customer history, know exactly the predicted customer lifetime value of this customer, if that's being calculated, all these different things, and then they can really know what to offer a customer right at the right moment. And so the chatbot has a really holistic view. So Regina says, thanks for the invitation. Thank you, Regina. Hope you're enjoying it. So let's move on now to another category, which is programmatic advertising. Again, this is another buzzword that you should go and Google after this, because programmatic is going to be big. So A programmatic is a totally new and exciting way of buying ads online, and it's all done using AI and machine learning and automation. So you have these programmatic advertising platforms, and they identify online consumers by things like their demographic, their geography, interests, behaviors, device, such mobile or tablet, current time and weather. And this data is usually provided by third-party vendors, so they have their own means of tracking what's going on around on the internet and building up these customer profiles. And so the programmatic advertising platform maybe buys this data and then identifies the best online audiences for various different marketing campaigns, and it automatically buys ad space at ad auctions. If you think about it, this is really remarkable. When you go onto a website, before you could even blink, there are ads that are being served that are based on, firstly, identifying different kinds of customers, then identifying that you are one of a certain kind of customer, and then identifying that people of your type of customer normally react in this positive way to this kind of ad, and then displaying that ad. It's really remarkable everything that goes on in a live auction. So the buying and selling of this ad space is also happening live, all automatically using AI. It's insane. And the result is personalized ads for every user. So there's lots of, and one last point before I elaborate a bit, of course, whether you then click on one of these programmatically displayed ads or not, this is called behavioral data, and this is going to inform future iterations. So the machine learning models will always be training, they'll always be getting better. And I just wanted to add that this is too big of a topic to talk about all in one go tonight, but you can certainly hit me up privately for some resources about this. There's lots of different techniques within it. I'll just give you a couple of examples. So serving ads based on a location, whether it's the location of where the user is or where your shop is called geofencing. So, you know, if you only ship within Austria, then you won't be displayed in Germany. This doesn't make any sense. So this is geofencing. And another example I'm sure you've seen. Have you ever searched for a product on a website, maybe even put it into your shopping cart and then not made the purchase? And then you notice that this product follows you around the internet no matter where you go? This is programmatic ads as well. So this is another technique called retargeting. But the next company in my local spotlight has an excellent blog post which goes into some more details about this, and you can also ask me about it because I happen to know the next company very well. It's my own, Smarter E-commerce, where I work. They don't know that I'm mentioning them here, so all of these companies today I have just found through my own engagement with the AI scene here in Austria, just a little disclaimer. But Smarter E-commerce, of course, I think they're great. They offer many services for pay-per-click accounts. So pay-per-click is people who are selling, for example, in the Google shopping universe. They don't pay unless you as a user click on their ads, and this is why it's called pay-per-click when they have those ads showing when you make a search. So Smarter E-commerce, or SMEC, we have services for such accounts, including a lot of machine learning based software and consulting and advice on programmatic advertising. So just write to me afterwards if you want to know more about that specific example. But we are now ready to wrap things up. So I just want to conclude by saying that AI-driven personalization is coming. That's because it's demanded by consumers, it's desired by marketers, and it's enabled by big data and machine learning. And I hope that you can see through all of these examples. I hope, by the way, that if you've got any questions, you're starting to type them to get them ready. But the power of AI-driven personalized marketing is twofold. On the one hand, you have the business view. So this is about engaging more effectively to improve business metrics. So of course, you know, spending the right money on the right ads in the right time and so on. And from the customer view, this is about engaging more meaningfully to provide better experiences. And just to bring this back to the reason why a lot of you guys are watching this, you're probably involved with Brainstorm, maybe studying the data science bootcamp already, maybe thinking about it, or maybe just thinking about getting into a career in AI, machine learning, and so on. Data science is a challenging and rewarding career. I really, really mean this, because every problem you're trying to solve it's a treasure hunt. You're trying to work out how you can get some kind of value out of the data and see into the future. And it can be applied to almost any problem domain. So even if you don't think you're going to be going into marketing, the techniques will be very similar for lots of different fields. And you can also get creative about what problems you want to solve. And a lot of marketing projects are managed using big data techniques and powered by applications of AI and machine learning, of course. So that's it for me. Does anybody have any questions for me in the chat or want to give me any feedback? While I'm waiting for you to type, I will just add my own details. Oh, they're already in the screen. I don't need to type anything in here. Okay, I have a question from Romulo. How real is it for a small business to get use of all these tools? Good question. I mean, tracking customers' behavior on their website, push them down the funnel and so on. Too expensive yet? Yes or no? Okay, thanks. Thanks, Romulo. So, a lot of these tools are actually available to many people. So, they talk about the democratization of AI and data and so on. There's a lot of libraries out there that are designed to make machine learning and so on a bit easier. So even somewhat small teams so small data science teams can start working with machine learning. The problem is more needing to have a lot of data. And this is something that a lot of customers don't realize that they're not ready for. So they want to build some fantastic, deep 10-layer neural network with however many parameters and so on to predict customer lifetime value, but they don't realize that they simply don't have enough samples for things like that. So the good news is, though, that there are more simple options available that, yeah, I would say a lot of companies can use as long as they have at least a couple of data scientists. You shouldn't be doing this if you have no idea in this field, because you could learn the wrong things and then make the wrong decisions based on that. But if you have a couple, then you can start working on it. But you do need to be aware that these projects also take a lot of overall development time. So from start to finish, you need to go through a whole pipeline for building, say, a machine learning model. You need to define the problem, then you need to identify the data that you will use, and of course make sure that it is clean and it has the labels that you need for training, so the real values that you will try to predict. You need to make sure that there's a lot of it and that there's always going to be a lot of it, that you're always going to be able to get more when you need it. Then you have to decide which aspects of this input data are the most important for the machine learning model. And of course, you need to know which machine learning model to use. There are many different algorithms. There's many ways you can train them. They all have different parameters that need to be tweaked. And then you need to do thorough testing, and then you need to very carefully deploy the model, and then you need to maintain it. So, I'm very lucky where I work. We have a nice big data science team, and we can do all of this. So, to try and answer your question more in a nutshell, there are technologies available for everyone that can do these kind of things. It's more a case of the expertise. We need the experts who actually know how to use them properly. But they are usually, they're free though. So about whether it's expensive, no, it's free to use a lot of these libraries and things like that. What ends up costing money is, for example, if you do have a lot of data and you don't have your own warehouse of GPUs and you use Google Cloud Storage, for example, then you're paying for the computation. Maybe you're buying data from third parties, things like that. That's where the expenses come in. Okay, do I have any other questions? Nice and clear. I thought the comment nice and clear was about my explanation. Now I realize it was about the audio issues from earlier. Okay, thank you, Celine. Okay, so if anybody wants to speak up now and ask a final question, they're very welcome to. Otherwise, just feel free to look me up on Instagram or follow me on Twitter. I do like to share resources on all of these topics, as well as some other topics I didn't get to talk about today, like AI ethics, machine learning, explainability, e-commerce, all these kind of things. So please feel free to get in touch. If you have any questions that maybe you didn't want to write in the chat, you can write them to me. You can also, I really encourage you to follow these few example businesses that I mentioned from Germany and Austria, because I think it's really good to support the AI scene that's growing here, and they're doing a lot of very interesting work. And yeah, okay, we've got one more question. How do we know if we already have enough data for applying AI to the business? Yeah, this question's a bit like, how long is a piece of string? So this is quite tricky to answer. People like to know something, rule of thumb, like, okay, if I want to predict numbers between 0 and 100, how many times more data samples do I need in my training data, things like that. But it doesn't work like that. What's important is to make sure that, yes, there is a lot, so get as much data as you can on the domain. Like I said, when I said about defining the problem, so be really clear about defining the business problem and what target value will you need to predict to be able to solve this business problem, and then make sure that your data is representative of that problem. So what that means is, let's say you have trained, or you want to train a recommender system for all the products you have in your web shop. And so you take 6 months worth of performance and product data from, say, March to September, and you train this recommender system. And then you go live in December. Now, the products that you have in December are probably very different to the ones you have in stock in June, and therefore probably the types of customers that are coming are also very different. So is your recommender system going to work? Not very well. So we would say there that the problem wasn't fully represented in the data because you didn't have all the possible use cases represented with a couple of training samples. So this is more important. It's, yeah, get as much data as you can, make sure it's clean and structured, but also make sure that it is very representative of the problem in lots of different ways, lots of different variations. Another topic that we have to leave for another day as well is an ethical one. It's about avoiding AI bias. So if you're actually doing anything that's going to be affecting humans, for example, using machine learning to determine risk in insurance and offer insurance policies, that's something where you're going to also need to be extremely careful to make sure you're representing all ethnicities, genders, and so on, because otherwise you might end up with a very biased model, which at best doesn't work very well, but worse than that, it might give you a very bad reputation or even get you into legal trouble. So it's too hard to say how much data do you need. You just need a lot, and it needs to be good. And I just thought of one little resource that is also useful for you related to your question. I'm just going to Google it and put it in the chat. So I have a link here. Copy link address. This is an article actually written by myself with an infographic made by me. It was written by myself and the other women in the Women in AI Upper Austria team, and this is about, can artificial intelligence solve my business problem? And this goes into your question, Romulo, of data quality and how much data you need, and is also just a really good overview in general of how to work out if AI is right for the problem. But I guess everyone's heard enough from me. I'm not seeing any more questions coming through in the chat, so I will just take the moment to thank you all again for your time. Thanks for sticking with us through a couple of tech issues at the beginning. Thank you to Brainster for having me, and I wish you all a wonderful night. So, thanks, and see you later.